And hello everyone. My name is Suhairi. I'm from MIMOS, government research agency in Malaysia. And today I'll be sharing with you our work on testing of distributed acoustic fiber optic sensor system using a customized disturbance simulator equipment. I'll explain later what does that simulator do. Okay, the sensor, for those who are not familiar about fiber optic sensor, this kind of sensor is unique in the sense that it can actually use a standard single mode fiber optic, which has been installed everywhere in the world in the telco infrastructure, in oil and gas, and also in utilities infrastructure. So the sensing based on scattering, naturally scattering phenomena in optical fiber, in particular in glass optical fiber. So the advantage of using this kind of arrangement is that you can actually sense events anywhere along the entire length of the fiber in a single fiber. Say, for example, you have 10 kilometers fiber. So anywhere along the 10 kilometers fiber, you can detect simultaneously the changes happening around the fiber and also in real time. So that's the advantage of using this optical fiber sensor. And in our lab, we are investigating the use of this kind of fiber for application, for example, like third-party interference, illegal digging of telco infrastructure, and also in pipeline leakages in oil and gas, and also in power cable theft. So if you have power cable and optical fiber embedded inside it, you can use it to, in our country, we have a lot of that kind of problem. People can just cut the copper cable and sell it to be a good price. So another thing you have problem on this soil movement along highways. So this is among the application that we are investigating. The issue with testing optical fiber sensor is actually in terms of sometimes the work done is in the lab, so you could not really understand the actual behavior of the sensor. And in particular, if the fiber is already installed in manhole or in critical infrastructure, it is exposed stress, temperature, and also weather. So it is important to have a setup where you can actually deploy the sensor for a continuous collection of data, characterization, also optimization of system. So we have invested within our campus so that you can control the environment for this kind of testing in our office. And these some of the pictures of the installation done below the planet and also on the grassland in our area. So this is the standard single mode fiber being installed, and the length of the fiber is about 1.2 kilometers inside the campus. And again, I mentioned these people running in front of our lab. Now, this is our lab. So there's a fiber optic installed on the floor. Again, as I mentioned, the issue of taking good data, continuous data, and a lot of data is manpower and also cost and time. So in this case, we had to engage our friends in the lab, which they should do some of the valuable things in their work. So we had to perform maximum of about half an hour only. We can engage this kind of activities. So it is not productive in terms of doing work. So we think that there should be another way of doing things so that we can actually get a lot of data for characterization. And again, there is another example of labor-intensive work that we are doing. We are testing the optical fiber sensor under the tarmac for our vehicle movement activities. So we have to drive and we have to close the road, and it caused a lot of problems to other people as well. So and there's nothing. We also tested the tanker which passes on the fiber optic of the road. So again, we had to stop cars coming in and out. So all this actually created difficulty in terms of doing research. So we proposed a simulator. We fabricated, customized this simulator which can perform several tasks. In this case, it's three tasks, three events, which correspond to three events. And this is mounted on a steel track, just like a railway track, and it can move to and fro repeatedly. So we can also customize it to sequence it for step-by-step movement as well. So this is the simulator where it can perform three events, which mimics the events such like digging using hand drill, movement of vehicle, this is rotation of tires, and also stepper, mimic the action of people walking. Okay, so this is the simulator that we place on our test site, and along the beside the railway track is the optical fiber, so that we can actually use it to sense. It is not necessarily close to the device or the equipment, but it can detect at least 1.5 meters away from the track. So this video is an example of the there's a video here actually. Okay, the movement of this simulator. So you can see that this is the wheel rotation, the drilling actions, and stepping action, all can be done within this one machine. And it is controlled by a PLC program where you can sequence it, as I mentioned, to perform sequence, be it a continuous movement to and fro, and also stepping in step. And it is controlled by this program, and it is connected to our lab wirelessly. So there won't be any people on site. You have people in the lab. The only thing that we still lack is having an eye, I mean a camera on the site. So that's something that we are working on. So once we have that, you can totally leave the site without any people, and you can just work in the lab. Okay, so this is the lab. The lab is using a commercial grade dust system, which belongs to our industrial collaborator. So we are testing it, and we are monitoring the events on site. And for the sake of having real deployment of the dust system, we connect another 10 kilometers of fiber. So in a sense, we have about 11.2 kilometers of fiber deployed on the client side. Okay, this is the result. You will call as a waterfall plot. So in this plot, you can see the simulation of stepping. You can see that this is the stepping simulation, meaning that in stationary. You can see that there's frequency every time there's a step at stationary position. And this is when the simulator move while stepping. Okay, and this one is the vehicle movement simulation. You can see that it is moving from this line of fiber to the other direction. Okay. And again, this is at the other end of the railway track, the movement of the tires. You can see that the distance is now different from the at the other end. And this is the drilling action of the simulator. And that is the drilling action, but at the middle point of the track assembly. And finally, this is just to illustrate that this is a drilling action as stationary, and this is movement of the vehicle or the simulator without any drilling, and it stops and it start drilling again. So this is how the waterfall plot gives out the result. Okay. So in essence, we have demonstrated the abilities to simulate three different events, which is walking, vehicle movement, and thinking, which correspond to the actual applications such as third-party intrusion. And we also have performed, able to perform tests on optical fiber at any point along the optical fiber, in this case 11.2 kilometers within our campus, as compared to laboratory test where you have to have a simulator, which is in this case is a piezoelectric stretcher. You splice it, you connect it to a fiber optic, and you see the response when you input frequency. So you want to see at the other end, maybe 5 kilometers away, you have to do the same thing. You have to repeat again, cut it and splice it again and again. So we have done the test without doing such a process. And nevertheless, the test is still at the stage, we still require a lot of optimization in terms of to quantify each of the events. For example, like the strength of stepping, which corresponds to the weight of a person walking, and also the speed of the digging. Because in actual implementation, digging can happen by manual digging or using excavation. So by having a quantity that can relate this strength of digging, it will also give values to the result that we are doing. So this is my contact. If any of you are interested, perhaps test together with us in our test facilities. And this work has been supported by our Malaysian government. So I would like to thank for your attention, and I welcome any questions.